So this is Algebra 1, Semester 1. It's the third unit called Graphing Linears. Linears is another word for lines. And it's the 8th lesson called Desmos Practice. It's on CreatorMathcom under the Algebra 1 tab. Please keep in mind you might have to Google CreatorMath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages, according to the table of contents, with the notes for those pages from CreatorMath.com. I always try to show that in these videos. Well, pretty much all the time I try to show that in these videos, because it can be hard for students to find. So let's see if I can pull that up in a reasonable fashion here. This is the name of the website, CreatorMath.weebly.com. Google that. If you Google that, you should get to this homepage. It looks like this. Now, a lot of students often have questions on the comp book because it can be complicated too. So scroll down on this homepage until you see composition book and read everything. Watch all the videos and follow all the due dates and put everything where it belongs, and then go back and make sure you're putting notes on the right pages, which I'm going to show you where those are right now. When we click into the actual class, or at least the video we're making right now, that tab, you'll see 4 different things in here. You'll see the notes, the video lessons like we're making now, the problem sets like we're going to solve right here, and of course the famous vocabulary. Just if you're not getting 100% on your vocabulary practices, you may not know that there is a complete PDF of all vocabulary words we will use for the entire school year. It is downloadable to your device, and it is searchable. So Google, how do I search a PDF on whatever type of device you're on, and it will explain to you how to do that. It's a little bit different depending on the type of device. Now we're going to find the right semester for the video we're in, and in your case for the class you're in. So here's the right semester for one we're making, and this is the table of contents. Please be aware that by now you should have written all of this table of contents into pages 2 through 6 of your composition book. It is long. It's probably about 3.5 pages, but it has every lesson and every page number that those lessons go on. So without that, you kind of don't know where anything goes in your comp book. So if you haven't done that already, please stop what you're doing now and do that. Now we're going to go to the unit, Graphing Linears. Now we're going to look for the lesson. In this case, it's lesson number 8. So here we are here at Desmos.com. It goes on these pages in your comp book. Here will be the notes. We'll open those in a second. Please don't take this video's word for it as to the page numbers, but look at the original table of contents. At the time you're viewing this, these page numbers probably might have changed. So we're going to go into notes. Here's the problem set we're doing now, and the video solution will be linked here. Fair warning, oftentimes when I open these notes, it can take twice to load it, depending on my internet connection. So this opened the first time, you'll be able to expand it on your screen and copy these into your comp book. It's usually not very many notes, but you kind of need some kind of foundation to understand what these problems are all about, right? So notes are a classic way, and believe it or not, still in college today, students are taking notes pretty much the old-fashioned way. Even with the internet classes and everything, we're still seeing note-taking going on just like it always has since the time I was in college. So that note-taking is great practice for you. So this is going to talk about y equals x plus 1, y equals 2x plus 1, and then what these graphs look like. Y equals x squared, y equals 1/2 x plus 1. And the whole point of this lesson is to get you to go and use Desmos.com. So I'll show you the graphs on my phone. Desmos.com, an accepted web-based graphing, online calculation and graphing tool. I like that. That's a pretty good definition. That's what Desmos.com is. A lot of your math teachers will use it. I know you use it in middle school. I know a lot of other teachers at my high school use it. So please get familiar with it. Your challenge nowadays is not so much memorizing anything. It's learning to use the tools you have and being able to switch and access them when you need them. So just to show that quickly here, if I do this, there it is, right there. Okay, that's Desmos.com. We're going to type in our equations right here, and we're going to see what we get. So let's go and look at the problem set. Let's see our first one. Using Desmos.com, match the following graph to the correct function. So here's a graph. Here's the x-axis, the y-axis, and here's the actual graphed line. It's a little hard to see. But if you look, it's going right to the origin, and it looks like it's rising 1 and running 1. So we can come up with this equation without that if we know enough about equations. We know y equals mx plus b. If it's going through the origin, this is 0. Okay, so that's gone. And if it's rising 1 and running 1, we know that m equals 1. Slope is rise over run. So if we take the y equals, and the x is always in there, and replace the m with a 1, it would be 1 times x, or y equals x. This is this equation right here. So I can figure it out. Now this is in function form. Function form just replaces the y with the f of x. Just watch a prior video to see how to put in function form. And then let's go to our graphing device here, Desmos.com, and let's type in that equation. So all we have to do is type y equals x. Notice it comes straight up through here, right through the origin, and it's rising 1 and running 1. And just to give you the background of the function notation, let's go and type in, literally do ABCs here, f parentheses x equals, and f of x equals x. So now, look at this. Now notice the green line. Look what we can do. We can turn off the green line. It's the red line. We can turn it back on. These are both identical. So these are different notations. This would be equation notation or graphing notation of y equals x, and this would be function notation of f of x equals x. Go back and see prior, I think the last lesson, lesson number 7, was on function notation, right? So we're going to graph that as we go. Let's go look at the next one. And I'm going to try to redraw the graphing because the printout's so bad here. This is the y-axis right here, right? This is the x-axis right here. And those are always the same. This is always x. This is always y, you guys. Always, always. It's foundational. This looks like number 1, and it looks like our line is passing through 1. And as far as slope goes, it looks like we're rising 1 and we're running 1. So we can say m equals 1 over 1 or m equals 1. And if we just go ahead and say y equals mx plus b, and if I were you, I'd go straight to the graphing device. I just want to give you this background to see how easy graphing can be if you kind of know what goes where. The y and the x stay in here. They always do because they represent the axes. All we have are b and m. This is the y-intercept. Where does it cross the y? Right here at 1. So you're going to have plus 1. And what's the slope? We said it was positive 1 or 1 here. We don't show a 1 times. We would just show y equals x plus 1. Notice it's in function form again. So let's drop in x plus 1. There it is. And look, so see how it's crossing right at, it's crossing the y-axis right here at 1. And this is our old line. Let's go ahead and modify this one to see, does the function notation match again? And the answer is yes, it does. Turn one off and on, right? You can see the other. Oh, this one's on top. So we can turn off the green, turn it back on. There it is, right on top of the other line. So function notation is exactly like equation notation. Notation is just a different way of writing it. I mean, think of writing in cursive versus writing in, I don't know, all caps or something, right? It's just notation that's changed. What you're actually writing is exactly the same. So using Desmos.com, let's match it up again. So now, where are we crossing the y-axis here? So we've got y equals mx plus b. So we always have the y and the x in there when we graph. The slope here looks like rising 1, running 1, so that looks like 1 again. And this y-intercept is at -1 here. This is the origin way up here, so this is -1, -2, so it's going to be -1 to show where does it cross the y-axis. So this would be y equals x minus 1. Here it is here. It's in function notation. I like that for each one. So if this is x minus 1, let's just modify what we've got. There it is. So now it's crossing at -1 right here. And if we go ahead and modify the function notation too, we'll see it's right on top of that one because they are equivalent or identical. There's the green, there's the red. There's the green, there's the red. Aww. So I think it's too hard for students. Once they get in the groove, they can do this very well. I think what's hard is remembering this, and then just from year to year, it's like it seems like students' brains reset each year where they're like, never seen this before, when I know you have. All right, where's it cross? Crosses at 1. What's the slope here? Slope looks more interesting. How many are we rising? So this is very hard to see, actually. It looks like it's crossing right there. 1, 2, 3, 4. 1, 2. So it must be crossing right here. 1, 2, 1. So m equals rise of 2 over run of 1 equals 2. And it looks like it's crossing here at y equal to 1. So if you have y equals mx plus b, y and x always just stay in there. The b is it's crossing right here at plus 1, so that's done. And the m we said is 2, so it looks like y equals 2x plus 1. And sure enough, 2x plus 1, it's in function notation. Let's try it in here and see if we get the same thing. And that's the point of this lesson, is to keep plugging it into Desmos to gain a little bit of trust of Desmos. And anytime you have a graphing problem from here on out, I mean, as long as your teacher is encouraging you to do so, like I typically do, then you can pull out Desmos.com and start typing in the graphs. And notice just the slope, just a comparison of slope. The green is a slope of 1. Oops. The red is a slope of 2. See how the 2 is a steeper slope. It's like you're climbing up a steeper mountain, right? That's an understanding of positive slopes. We know it's positive because it's positive here and here. Let's go ahead and change this to match, just to show that the function notation matches. This one. There it is. Green on, green off is red, green on covers it up, and so it's red on top. Alright, not too bad, but we're learning how to use our technology. It works real well on your phone too, as I'm illustrating. Most students can resonate with that. So here we are, we're crossing this at plus 1, so y equals mx plus b, right? The y and the x stay in there. The m is a slope. Where is it crossing? I see here, right? Doesn't it look there and here, and it's really bad. So I'm doing my best to see, but I see that crossing the grid. So this would be a rise of 1 and a run of 2. A rise of 1 and a run of 2 would be 1/2 would go in for m. It's crossing right here at 1, so it would be plus 1. So y equals 1/2 x plus 1. F of x equals 1/2 x plus 1. F of x and y equal to, right? Those are equivalent. They're just changes in notation between equation form or graphing form or Cartesian coordinate form and notation of a function form. Okay, f of x is function form. Okay, and it says match the following graph to the correct function. Nice. So they are matching their notation with their language here. I appreciate that. Since I wrote it, I often make mistakes. So go here. Let's type in 1/2. 1 divided by 2. And is it plus 1? Yeah, it's plus 1. So there it is right there. Notice a red line. Notice how this slope is much more mild, 1/2 than the 2. The 2 is really steep, the green, right? Let's match it. Make this 1/2. Delete this out and say 1 divided by 2 to do 1/2. And you get the 1/2 right in front of the x. That's the slope. And once again, it's right on top of the other. Turn this off. There you go. Turn it back on. Right on top. Let's do another. Again, we're crossing at plus 1. Y equals mx plus 1. I'm going to drop it straight in for b, if you'll allow me. All right, now, the slope on this one's negative. This is a negative slope. Down and to the right, up and to the left is a negative slope. Positive slope is this way. Zero slope is this way. Infinite slope is this way. So this is a negative slope. So we're going to have to count. Let's start here. Where does it cross? Does it cross here maybe? And here. And I'm so sorry. Actually, it looks better on the camera than when I'm looking at it. But what do? We go down 1, 2. So remember, rise over run, but in this case we're going down 2 over run is 1 to the right. So slope here equals -2. So y equals -2x plus that 1. F of x equals -2x plus 1. Let's check it. Go to the right. Let's get rid of this. Let's put in the -2x plus 1. Okay, there we go. There's the green line. There it is, the red line. And then notice negative slope. Green is positive slope up to the right. Red is negative up to the left or down to the right is a negative slope. So sure enough, we have a negative slope. This one's positive. Let's change this one out to the -2, and now we'll see that the function notation matches. -2. Oh, we can turn one off, turn it back on. It's overlapping, right? Or they're the exact same thing, whether it's y equals or f of x equals -2x plus 1. The great thing about function notation, just to remind you from last lesson, is you can plug in a value for x like f of 1, and then it's -2 times 1 plus 1. Okay, so f of 1 in this case is equal to negative 2 plus 1. F of 1 is equal to negative 2 plus 1 is negative 1. So this is an input of 1. This is an output of negative 1. Independent variable is being input. Dependent variable is being output. It's dependent because this is created by this expression. Okay. Quick review of what we covered last lesson. All right. Looks like graph's getting worse. This is 1. Y equals mx plus 1. We'll drop that straight in. Y equals, we want to know, what is the slope? The slope in this case is negative. Where are we crossing our grid? Here's a crossing the grid. This looks like crossing, and this looks like crossing. It looks like a negative 1 to come down to here, and a positive 2 to go to the right. Negative 1 over 2 is a negative 1/2. So negative 1/2 x plus 1, negative 1/2 x plus 1 in the function notation. So negative 1 divided by 2 will give us negative 1/2 plus 1, and that's the red right there. There it is. And then let's modify the function notation too. And notice the fractional slopes are not as steep as the whole number slopes, right? Those get a lot steeper, a lot quicker. Oops, I took out this one, divided by 1, divided by 2. There we go. Turn off the green. There's the red. Turn it back on. It's right on top. These are equivalent, whether you say y equals or f of x equals. One is an equation notation. The other is a function notation. So look at this. Here's your line. It's cutting through 1. So start with the same process, you guys. Don't freak out, because that's what I would always do. I'd be like, wait a second. I don't know how to do this. Yes, you do. Start with y equals mx plus b. Repeat the x, the equals, and the y. All we need to know is a slope and a b. Where is it crossing here? At 1. So this is going to be plus 1. What is the slope? Well, is there a rise? No, it's 0. There is no rise over run. So literally, this is a 0 slope. We don't rise any to go to this. We rise 0. And do we run any? I don't even, if all this is a run, it doesn't matter. Once you have that 0 in the numerator position, this whole fraction 0, right? So 0 times x makes it disappear. There's no more x in there, and you have y equals 1. F of x equals 1 is your function notation, and prove it to yourself. Take all this out and leave it just y equals 1. Oh, look, 0 slope. Modify the function notation to match. Oops, okay, I did too much deleting there. Oh, please hold. There we go. F of x equals 1. And turn the green graph off. There's the red. The green's right on top of it. These are equivalent notations in terms of value. All right, make sure. Oh, sorry. I got more. Oh, how fun. All right. Well, I know this is a parabola, and now I am going to go for the directions. The direction says use Desmos, so I'm going to say, I don't know what this graph is, so let me type them all in, right? Let's get rid of this. Let's just pick one. Let's just do y equals now. Y equals x squared. See that button for squared? X squared, that's x to the power 2. Notice it's a parabola. There it is. Y equals x squared, and let's do the next one quickly. And let's just see what happens if we put a negative in front of the x squared, minus, it flips the parabola opening now downward. So a negative makes our parabola open downward, and a positive makes our parabola open upward. Both are passing through their vertex, touching the origin here, right? So I know we're in the subject of graphing linears, but what helps you to understand graphing lines is to understand what comes next, which is graphing curves, and a parabola would be considered a type of curve or a non-linear graph. All right, make sure you're matching up the title of this video with the actual problem set you're doing, otherwise it won't make much sense. This is Algebra Semester 1. It is Unit Graphing Linears and Lesson Desmos Practice number 8. It's on CreatorMath.com under the Algebra 1 tab. Hope this helps.